So without heavy breathing or sounding too boring, we're going to talk about lenses and refraction. So the first thing we have to know and remember from year 8 is that refraction is the bending of light, as you can see in this diagram here. So as it goes from one medium, the vacuum, to another, the speed of light will change. And if it comes at an angle, then that means that it would also change direction, as you can see in the diagram, that this ray of light here is changing in direction as it goes from vacuum to medium. And lenses use this principle of refraction in order to form an image. Okay, so you've got two types of lenses. One which is called a converging lens, or what we know as in GCSE science as a convex lens. So you've got convex, which is this type, and this type which is concave. And both of them will form an image by using the idea of refraction, which we saw in the previous slide. So a convex lens, the one which is here, takes in parallel rays of light, so rays of light coming straight, and because it's got a curved surface, the rays of light are refracted or bent, and in a convex lens they bend towards a point, which is called the focal point here, which is on the other side of the lens. Now because light can travel both ways through a lens, so it can come in this way, and go back the other way, or indeed come in the way on the diagram, then you have two focal points, one on either side. And in a concave lens, so the one down the bottom here, B, the rays of light come in and hit the surface of the lens, and instead of converging, as they do in this one, they diverge, they spread out. So that's why it's called a diverging lens, because the rays of light, when they hit the lens material, then they will spread out. The distance between the lens itself and the focal point, the point where the light meets, or the rays of light meet up for the lens, is called the focal length. So it says FL here, that's the focal length, the distance between the two. So here's my object, our stick man over here. Okay, and a lens can form an image of this very attractive stick man right here in a number of ways. So what can happen is you can either have a stick man who is magnified, so much bigger, or one who's shrunk, so a lot smaller. Get him upright, and it can be upright as it is on at the moment, or it can be inverted, which means that he's upside down. And just to show you that real images are formed when the rays of light which come through the lens simply come together. So both of these rays of light are still real rays of light, and we'll come on to that in the lesson as well. Whereas here in this one you've got an image which is a virtual image. It's called a virtual image because, just out of the way there, the rays of light from the object, when they go through this lens, this concave lens, they diverge. So at no point do these two rays of light meet, this one here or this one here. And so the image never forms behind the lens, so this side, it actually forms here, and it's called a virtual image because one of the two rays of light is a virtual ray here. So you get a virtual image, which basically means it's not formed by real rays of light, as in this case down the bottom here, this one. Okay, no shame here, this has come from a website and I'll give you the link later on, but the first step in drawing a ray diagram is to draw your object on with the arrow, the black arrow here. So that'll be your object. In our case it'll be the stick man, but we're going to simplify and just make it a tall arrow. Now it will sit somewhere between 2F and F in this diagram, and that's fine. We're going to draw that ray up to this principal axis, which is basically the middle of your lens, marked on as a dashed line. Okay. So remembering that you've got to draw all your rays of light with arrowheads on them, then the next thing to do is to draw the next line which goes from the principal axis, the centre of the lens, through the focal point. So notice one line to the lens in the middle of it, the next line goes through the focal point. And this is for, just so note, this is for convex lenses and not concave. So convex, step 2, draw the refracted ray passing through the principal focus, i.e. the focal point here. Again, arrowhead. Step 3 is then to draw a second ray which simply goes from the object, the top of the object, through the centre, the middle of the lens, and then all the way through. And so now what you have is a point where those two rays cross over. And then step 4, simply draw on an arrow from the axis here down to where the two rays cross. So now you've formed your image. That is your image there. So in this case, the image is inverted, it's upside down. It's real because it's made of, or it's formed by real rays of light, and it's magnified, it's bigger than before. So remember, we've just looked at how to draw a ray diagram for a convex lens. Okay. We also have to look at how to draw a ray diagram for a concave. So for a concave lens, it's very similar to what we drew before. You've got your object somewhere on the axes. This is your lens, again it's just a dashed line, so remembering that if it's concave it has that sort of curved shape, so it looks a bit like a cave. And one of your rays of light will simply go from the object through the centre of the lens and just continue on. The second ray has to come from the top of the image, sorry, the top of the object, not the image, top of the object, and go to the centre of the lens, and then it diverges, it goes out. Now that, how you mark on that diversion is to take your ruler, put it on that point, and align your ruler with the focal point. So you've got a long straight line all the way along from the focal point to there, where the centre of the lens is and where the ray meets, and extend that ray back. But when you extend it back, that is a dashed line because it's not a real ray of light. So you get a point where they cross over, you mark on that arrow just like we did before, but this time it's upright, it's smaller, and it's not real, it's a virtual image. So what we intend to look at in the lesson is how to draw these ray diagrams. We'll practice drawing this one and the one before, and look at how the size of the image and the nature of the image changes as we move the object to different distances compared to where the lens is. So it might be that it's at the focal point at 2f and different distances along. So you have to be able to draw these diagrams and also describe the nature of the image that's formed.